So now we'll get on to talk about groundwater quality. The main concerns with coal seam gas activities are that they will impact on groundwater quality, and this in turn may affect other users, including irrigation, town water supply, stock and domestic, human health and other environmental assets. We're now going to look at baseline monitoring data, potential groundwater quality risks and how these risks are managed. So baseline groundwater quality. One key to note on this slide is you can see the sort of technical setup that you have to do water quality monitoring. It's a very expensive business, water quality monitoring. You're talking about taking groundwater out of a bore. You need to pump it. These bores might be a couple of 100 metres deep. There's not a lot of pumps that can pump water from that deep successfully. You're also talking about taking a representative sample. So if that bore's been sitting there for a year without being pumped, you've got stagnant water. So you need to get all of that water out of the hole from this tiny little pump at 200 metres and take a good clean sample. When we talk about baseline groundwater quality information, we are referring to the results of chemical analysis of groundwater samples. So why is groundwater quality monitoring important? In essence, water quality monitoring helps us better understand a groundwater system and its connections, providing baseline data sets to characterise natural variations over time and to detect changes in groundwater quality resulting from human activities. Governments, mines and the coal seam gas companies all have roles to play in the collection and interpretation of groundwater chemistry data. The New South Wales Government has collected groundwater quality information from its monitoring bore network. While some comprehensive sampling has occurred in the past, continual data collection is not routinely undertaken. In general, widespread government analysis has focused on salinity. This is because salinity is a key indicator of groundwater suitability for various purposes, drinking water, irrigation and stock watering, for example. There have been some very detailed chemistry sampling programs undertaken by government over the years, but these programs have been project-based and are not ongoing. The very high cost of detailed chemistry sampling is a key consideration when justifying long-term continuous monitoring programs. Coal seam gas companies need to understand their groundwater chemistry in detail so that the optimal use and/or treatment of produced water can be determined. The quality of the groundwater is an important factor influencing coal seam gas operators' decisions about management of produced water during production. But more recently, with companies coming in, they need to understand the more comprehensive chemistry of their systems, and they're designing water quality analysis suites that look something like this. So this is a typical example of what a Santos or an AGL would take in their monitoring suite. This table is an example of the standard suite of chemical analysis that coal seam gas companies routinely undertake from their monitoring bore networks. You can see how comprehensive the table is, with simple field parameters on the left-hand side, moving across to high-end chemical analysis on the right. Isotopes are now more routinely used to better understand the age of groundwater and the flow dynamics. Fingerprinting of water can assist with determining the degree of groundwater mixing between overlying and underlying groundwater systems and the age of the water. Water quality testing by industry is undertaken routinely. The frequency of sampling is dependent on the hydrogeology, the stage of the project, and ranges from monthly to annually. More responsive systems such as alluvium are generally sampled more frequently than the deep, slow-moving porous rock groundwater systems. So if we have a look at risks to groundwater quality, so you can pretty much break that into two areas. Firstly, risks from underground work such as exploration drilling, ongoing operation and long-term integrity. Fracture stimulation is one of these risks, but is not considered further in this presentation, as Santos are not proposing fracture stimulation at the Narrabri project. Secondly, risks from the storage and management of produced water at the surface.